Okay, 43. These ones, now we're going to apply using the product rule, quotient rule, etc. For what intervals is this function concave up? Well, f is concave up if f double prime is positive, right? Second derivative is positive. It's concave up. So we've got f of x equals x e to the x. So we're going to find the second derivative. So f prime of x is the first derivative of the second plus the second times the derivative of the first. And I'm going to go ahead and rewrite that, as you'll see, y e to the x times x plus 1. So we got that. And the reason I factored the e to the x out is because now this is a product to find the next derivative, and it makes it a little bit easier. You don't have to do it this way, but it's, I think it makes it a little nicer anyway. First, e to the x derivative of the second plus the second times the derivative of the first. And if I factor e to the x out, I get 1 plus x plus 1, or I get e to the x times x plus 2. Okay, so now this one involves you a little bit of thinking on this part. I want to know, where is that greater than 0? Because it says for what intervals, so what x values? Well, I know e to the x is always positive no matter what, because I know that the graph of e to the x goes like this. So we're kind of pulling a bunch of things together here. So if this is always positive, we want to know, when is this positive? So I want to know x plus 2 is positive whenever x is greater than negative 2. So if x is greater than 2, then f double prime of x is positive. So f is concave up. Alright, there's 43, 44. Same type of thing here. We want to know, where is g prime concave down? That's when the second derivative is negative, so let's find the second derivative. So g prime of x is the bottom times the derivative of the top, 0, minus the top, times the derivative of the bottom, all over the bottom squared. So if I simplify this, I get negative 2x over x squared plus 1 squared. And I'm trying to find where it's concave down, so where is this negative? That's my question mark, or question there. Well, the denominator is always positive. Okay, so I just want to know, for what values is negative 2x negative, right? Because if the numerator is negative, then the quotient's negative. So whenever x is less than 0. Does that make sense here? Let's think about this here. When is this negative? Oh, oops. Forgot to switch my signs when I divide by a negative number. So what we're saying is, whenever x is greater than 0, this numerator is negative because it's a negative times a positive. And so that would make the whole thing negative. So whenever this x is positive, this fraction is negative. Does that make sense? So if, well, I'll just rewrite it. So if x is positive, then guess what I just did? Shucks, I did the first derivative. Sorry, and because I already did that last problem on here, I want to not start over. So apologies on that one. I'm going to do the second derivative because we're talking concavity here. All right, so let's do this. So g double prime of x is the bottom times the derivative of the top minus the top times the derivative of the bottom. Oh, we don't know how to do that yet. We don't know how to do that yet because of the chain rule. So why is this problem here at this moment in time? I'll tell you what, let's hold off on 44 until we know how to do the derivative of this guy. Not sure why this problem's here right now in this section. So don't worry about that right yet. we'll hit it in class because we'll be able to do it now that we know how to do the chain rule after the next section. Okay, and 45. Boy. Find the equation of the tangent line to the graph. My dog's going crazy. Probably sees a squirrel or something. She thinks she can catch it, but she can't. Okay, equation of tangent line. We got to find the slope and the point at which it's tangent at. So when x is 0, I know y is going to be -5. So that's my point. And the derivative would be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And I want that derivative at x equals 0, so I'm going to find f prime is 0. It's going to be 2 minus -5 all over 1. So it would be 7. So my equation would be y plus 5 equals 7 times x minus 0, or y equals 7x minus 5. Okay, there we go. And again, sorry about this problem 44 and messing it up twice. So we'll hit that in class.